Engineers have people's lives in their hands. A flawed foundation can lead to disaster, and buildings can collapse without warning. You can't build up unless you are absolutely sure the foundation is secure. Engineers need to know whether the foundation is strong enough to support tremendous weight. This is the traditional way of testing foundation piles, and it's still popular with structural engineers. It's called a static load test. This test is part of a huge $500 million construction project in Providence, Rhode Island. A major section of the I-95 is being moved, and new ramps and a bridge will need super strong piles to hold it up.
We're load testing this pile to 120 tons, which is equivalent to approximately 250 to 300 cars stacked up on top of it.
Massive amounts of steel and concrete are stacked on top of a huge test pile in the ground. Sensors in the pile measure the amount of weight. It tells them how heavy a load the pile can take. The entire test takes about 4 days.
Good. Number one. Good.
It's the old-fashioned way of doing it, and it works. But it requires a lot of equipment, space, and takes a long time to complete.
5, 4, 3, 2, 1.
Today, the creative engineers at Birminghammer have come up with an explosive way of putting foundations to the test. It's called Statnamic, and takes foundation testing to a new dimension. It's Newton's Law 101. For every action, there is an equal and opposite reaction. Here, the force of the explosion is directed upwards against the weights on the machine. This produces an equal and opposite downward force on the pile buried deep in the ground. Test engineers want to measure how far the foundation moves as a result of that force. That's crucial information for the construction of bridges and buildings. A small but powerful explosion creates the force. All it takes is some igniter wire, a 12-volt electrical charge, and some fuel pellets. This small charge packs 30 tons of downward force on the foundation. Incredibly, that's the same amount of force that was being tested in Rhode Island. What took 4 days and loads of equipment can be done in a matter of minutes.
The fuel that we use is solid propellant, and I can just demonstrate how it burns. The purpose of the fuel is to generate gas pressure. And when you confine the fuel in a small area, that you can make good use of that gas pressure to produce force.
Lasers combined with load cell technology provide instant answers.
We can know immediately if the pile deflected and the magnitude of the deflection. Did it move an inch? Did it move half an inch? We can see that instantaneously. And that'll tell us whether we need to do further testing or whether this pile is going to be a good pile.
But this is just a baby Statnamic device. The big guy is ready to go south of the border.
We're under the I-95 in Milford, Connecticut, and we'll be load testing a foundation that will be used for the widening of the highway. And the pile foundation today is called a drilled shaft. It's about a 30-inch diameter column that goes from the top of the ground down to bedrock. And we'll be applying about 1,800 tons of force using the Statnamic load test method to this pile today.
Applied Foundation Testing owns the biggest Statnamic device in North America. There's no way they'd be able to do a conventional static load test here.
You can see the physical restrictions on this job site present a challenge to construction. So you can only imagine the challenges of bringing 100 trucks of this size into a job. The Statnamic method allows us to bring only 5 truckloads of equipment to perform an 1,800-ton load test. The other advantage is that it can be done all in one day.
The piston is filled with pellets.
This part of the Statnamic equipment is called the silencer, and this particular model weighs about 9 tons. The bottom part is the cylinder, much like the cylinder in an engine in your car. The yellow part is, we call the silencer. It operates much like a muffler in your car, and that just reduces the amount of noise that's emitted from the Statnamic device when the test goes off.
The silencer is lowered into position. These blue blocks provide the weight needed for the test. They will be piled on top of the combustion chamber. Remember Newton's law? When it fires, high-pressure gas will propel the weight upward at a force of 20 Gs, creating 1,800 tons of downward force on the pile.
The critical information that comes from this test is how much load can the foundation hold, and can it hold enough for the future bridge that's to be built on top of it?
It's growing dark. They only have one shot at it. More than 2,000 sensors digitally record signals from the test. Within minutes, a computer in the nearby trailer is spewing out data. Engineer Christopher Lewis is suddenly the most popular guy on site. This graph shows that within a fraction of a second following the explosion, the pile was displaced just over 7.5 centimeters. They now know the breaking point of the foundation.
We got what we wanted.
With that information, the Connecticut Department of Transportation can begin designing foundations for their new bridge.
We got the data that we needed to come up with a reasonable design that will be economically feasible, and to me that's a good day.
Driving piles and drilling holes is not glamorous work, even by construction standards. But without hammering, grinding, and vibrating deep into the earth, the biggest bridges and buildings wouldn't have a leg to stand on. Their work is on the frontiers of the greatest construction on the planet.